Again, welcome to DSRT 734 class. These lectures cover geometric and Poisson discrete probability distributions. So our main objective is we're going to learn how to find probabilities using geometric distribution and also using Poisson distributions. And both of them have different conditions. So we start with the geometric distribution. With the geometric distribution, first is a discrete probability distributions, and it satisfies the following conditions. A try is repeated until a success occurs. And also the repeated tries are independent of each other. And also the probability of success P is constant for each try. And then probability that the first success will occur on try X is P at X equal to P times Q to the power S minus 1. Q will be the probability of failure. So Q equal to 1 minus P. We know total probability is always 1. So if the success is 0.7, then the failure will be 0.3, which is Q. So let's see an example. Here they say from experience, you know that the probability that you will make a sale on any given telephone call is 0.23. So the probability of not making sale or making the phone call will be 0.77. 1 minus 0.23. So Q will be 0.77. Now here they say find the probability that your failed sale on any given day will occur on your fourth or fifth sales call. This means X will give us 4 and another X is 5. So we will say, okay, probability that the sale on fourth or fifth call will be probability of 4 plus probability of 5. Again, S is 4 and 5, which represent the number of calls, fourth and fifth sales call. So geometric with P equal to 0.23, this means Q will be 1 minus P, which will give us 0.77. X is 4 and 5. So to find the probability of 4, first we need to find the probability of 4 first, then we find the probability of 5. And we know this is addition rule of probabilities because the question said or. The given day will occur on your fourth or fifth. So we know probability of A or B will be probability of A plus probability of B. So here we find the probability of 4 first, which will be P 0.23 times Q 0.77 to the power 4 minus 1, which gives us 0.05003. Then we find the probability of 5, which will give us P will be 0.23, Q will be 0.77 to the power 5 minus 1. So that will give us 0.080852. So the probability of sale on fourth or fifth call will be probability of 4 plus probability of 5, which will give us 0.10505003 plus 0.080852. And that gives us 0.186. Now let's go to the Poisson distribution. With Poisson distribution, again, it's a discrete probability distribution. Also, it satisfies the following condition. The experiment consists of counting the number of times an event X occurs in a given interval. Also, the interval can be an interval of time, area, or volume. So again, Poisson distribution we use to calculate the probability of an event occurring over a certain interval. And the interval can be distance, volume, area, time, etc. So the probability of event occurring is the same for each interval. And also the number of occurrences in one interval is independent of the number of occurrences in other interval. So this is not a conditional probability. So a Poisson distribution, the probability of the event occurring is the same for each interval, as we said earlier. So, and this is the formula: probability of X equal to mu to the power x, the mean will be the average or the mean, times e to the power negative mu. E is exponential function divided by x factorial. E is a constant value. E is approximately 2.71818. Mu is a mean number of occurrences. So let's see an example. Here we said the mean number of accidents per month at a certain intersection is 3. What is the probability that in any given month, 4 accidents will occur at this intersection? So here the two values that we need is already given to us, which is the mean and also the x for accident. Also, based on this question, it's a Poisson distribution because it's based on interval. What is the probability that in any given month, so it's an interval of time, 4 accidents will occur? So this makes this question a Poisson distribution. It's based on interval of time. So again, S is 4, the mu is 3. So probability of 4 accident is 3 to the power 4. As we said, mu to the power x times e to the power negative mu. So we get 2.71828 to the power negative 3 divided by x factorial, which will be 4. Roughly the answer will be 0.168. Now with binomial and Poisson, we say the difference between the two is that while both measure the number of certain random events or success within a certain frame, binomial is always based on counting. So it's a discrete event. How many planes will be late, or how many flights will be late at some certain period due to some certain condition. But Poisson is based on what? Interval events within some interval of time or area, etc. So Poisson is based on continuous events since it's based on interval. So in summary, again, we learn how to find the probabilities using both geometric distribution and also Poisson distribution. Again, thank you for your time. See you in the next lectures.